Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 25th, 2025, about 2 days ago. It introduces a normalizing flow-based video generator that can produce high-quality, temporally consistent videos in an end-to-end, causal way, matching or beating strong autoregressive diffusion baselines while still giving exact likelihoods and practical sampling speed. The paper is titled STARFlow-V, End-to-End Video Generative Modeling with Normalizing Flow. And, as we will see later, the approach could reshape how future world models handle long, streaming video. Also, the authors shared an official GitHub repo for STARFlow and STARFlow-V. Inside you'll find the full PyTorch implementation, training and sampling scripts for text-to-image and text-to-video, config files, dataset and utility modules, conda setup helpers, plus example shell scripts to quickly run generation or kick off your own training. Alright, after hearing about the code release, Figure 1 shows what the model actually produces across different tasks. The top rows illustrate text-to-video generation, where a single prompt leads to smooth, high-resolution clips like erupting volcanoes or moving animals. The middle block presents image-to-video generation, and the red boxes highlight the initial conditioning frames. The bottom block demonstrates video-to-video editing, where instructions like style change or outpainting reshape the original clips while preserving motion. Well, Figure 2 illustrates how the model turns text and random noise into a clean video. The left side encodes a text prompt and stacks pure noise frames, which feed into a deep autoregressive block that captures global across frame context. These global features then pass through several shallow local blocks that refine each frame's spatial details. The right side adds slight noise again, and a lightweight causal denoiser cleans it up, so the final video is both sharp and temporally consistent. Alright, Table 1 summarizes how different video generators score on the VBench text-to-video benchmark, which rates overall quality plus aspects like semantics, object handling, and human depiction. Closed-source diffusion systems still lead with total scores in the mid-80s. Autoregressive diffusion models cluster in the high 70s to low 80s. The key point is that the normalizing flow entries for STARFlow-V reach about 79 to 80 total, matching strong autoregressive diffusion baselines while staying fully invertible and causal. So Table 1 compared overall benchmark scores, and Figure 3 now shows what those differences look like frame by frame. The left block contrasts a sunglasses dog video, where Nova gradually blurs, and WAN 2.1 causal FT collapses into messy artifacts, while STARFlow-V keeps sharp details and consistent identity. The right block repeats the story for a colorful bird over 30 seconds, where competing autoregressive diffusion models drift, blur, or deform, but STARFlow-V preserves clear structure and stable colors. This visual comparison highlights stronger robustness to exposure bias in long rollouts. Alright, Figure 4 analyzes how the blockwise Jacobi iteration affects speed. The left panel shows that increasing block size first speeds up sampling dramatically, hitting a sweet spot where each frame takes only a few seconds, before slowing slightly for the very largest blocks. The middle panel tracks how many Jacobi iterations each latent frame needs, which drops with better settings. The right panel shows that video-aware initialization consistently cuts per frame time, especially for large blocks. So Figure 4 focused on speed, and Table 3 turns back to quality for strictly autoregressive video generators. The top rows list diffusion-based systems Nova AR and WAN 2.1 causal FT, which reach total scores around 75 on VBench. The bottom row shows STARFlow-V at about 80 total, with especially strong object, human, and spatial scores. This gap indicates more stable, long-horizon videos under autoregressive rollout. So, the big message is that a carefully designed normalizing flow can actually rival strong diffusion models for long autoregressive video while staying fully invertible and likelihood-based. That opens the door to more principled, streamable world models for interactive media. That is it for this episode of AI Research Roundup. I am Alex. Thanks for listening.